Hello Algebra 2 students, this is Miss Prater. I'm making this video for section 7.02 and 7.03 because I had to be out of the office today and I canceled our whole group this morning at 9:15, so I did want to send out this lesson that I had planned to do in our whole group today. So it is 7.02 and 7.03. Let's just kind of get started here with the words opposite, and let me pick a yellow. Opposite, and I know you've heard that word, you definitely probably know what it means, but when we're thinking about a right triangle, this is always something that some of my students struggle with, but let's name this triangle ABC. And if I was talking about the side opposite of angle A, so we would have to walk across the triangle opposite, so the side opposite from angle A would be side BC. So this side right here. So we're just going to kind of talk about, in reference to a right triangle, what does opposite mean and what does adjacent mean. So let's jump down here. Let's look at adjacent. I think I can use the hot pink for this. So if we're talking about adjacent, a fancy word for adjacent is juxtapose. For those of you that read a lot and have a really big vocabulary, I just think of adjacent in math. But if I'm looking at another right triangle, and we'll label it also ABC. By the way, this little box is the label for a right angle. If I were looking for the adjacent to angle A, then it's going to be the side right next to angle A. In right triangle trig, we cannot ever use the hypotenuse, which is the side opposite of the right angle. The hypotenuse can never be the adjacent leg because it's specifically considered a leg, which a leg is never the side opposite of the right angle, called the hypotenuse. So when we're talking about adjacent, we're talking about the side, specifically the leg, which is not the hypotenuse, the leg that's going to be adjacent to angle A. So I'm just going to circle the A in both of those right triangles. So the yellow represents the side opposite angle A. The hot pink represents the leg adjacent to angle A. And we can't use the hypotenuse in either situation, okay? When we're doing right triangle trig, we're not going to ever use the hypotenuse because we're going to use one of these legs, and the legs are always the two sides of the triangle that form the right angle. The legs are always the sides of the right triangle that form the right angle. So I kind of wanted to talk about that. If we would have been able to have our live class connect, that would have been my do now, talking about what opposite means specifically in reference to right triangles and what adjacent means. Let's take a look at Always Believe Something Wonderful is About to Happen. This is our announcements for the week. Monday was Veterans Day. Tuesday we start Unit 7, or continue with Unit 7. We started Unit 7 last week. Unit 7 is the very last unit for this semester. I'm super excited about this. It has 13 sections, so we're going to stretch it out this week. We're going to stretch it out next week. We're going to go on vacation for a whole week for Thanksgiving break. We're going to come back and we're going to finish Unit 7 the week after Thanksgiving, and then the next week we start reviewing for the semester exam. So remember, if any of y'all think that you might be able to be exempt, start looking at your grades. You have to have a 90 or above in each class. You have to make sure that anything that is required, an assignment that is required, you cannot have a 0 for anything that is required. So that would mean no bonuses. Don't look at your bonuses at all. Make sure that all your required work, you've turned in assignments for those. You have no 0s for any required work. You have to have taken the STAR reading and math for your beginning of the year testing, and you cannot have any disciplinary reports. Most of the time that doesn't happen in math. It has something to do with plagiarism. Most of the time y'all are not plagiarizing in math. Who would do that? Anyway, today we're going to be looking at a course of study for Algebra 2 in the state of Alabama, objective number 12, simplify equations involving exponential, radical, log, trig functions. We're focusing on the trig. We've covered this objective before, but we've been looking at the log and the exponential part of the objective, and today we're going to be looking at the trigonometric. So, big slide here. There's a whole lot of stuff that I jam-packed in this slide, and when I send this out to you by video, I'm also going to give you the whiteboard link and also the PowerPoint link, which is also in the announcements. We put the links, though, they're now in the announcements, so you could also find them in the announcements. This would be a great resource for you to save. And so when I think about right triangle trig, so this is what we're going to focus on today, right triangle trig. I think about having to memorize sine, cosine, tangent, and then a little bit later on, you're going to have to memorize cosecant, secant, and cotangent. But as far as memorizing, it all starts with memorizing the ratios, okay, of sine, cosine, and tan. Then cosecant, that's what CSC, and I've got abbreviations over here for you in this reference sheet. Cosecant is just the inverse of sine. So instead of it being opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is the inverse of cosine. So it would be, flip it over. Cotangent is going to be the inverse of tangent. So to me, I always teach my students, or when I learn this, I memorize sine, cosine, and tangent. And then I memorized cosecant was the inverse of sine, secant was the inverse of cosine, cotangent was the inverse of tangent. So how do you memorize sine, cosine, and tan? Well, most of my students nowadays will tell me that somewhere in Algebra 1 or geometry, their teacher taught them something called SOHCAHTOA. They might have pronounced it differently, but if you kind of try to pronounce SOHCAHTOA, it kind of sounds like SOHCAHTOA. It stands for sine is opposite over hypotenuse, O for opposite, H for hypotenuse. Cosine is adjacent over hypotenuse, A for adjacent, H for hypotenuse. Tangent is opposite over adjacent. In my day, we taught this little saying that said some old hen, sine opposite hypotenuse, caught another hen, cosine adjacent hypotenuse, taking oats away. Tangent equals opposite over adjacent. So I don't care how you memorize it, but you really, really, really need sine, cosine, and tangent memorized when you take the ACT, when you move on to other courses, when you go to college, if that's something that you choose to do. They're going to expect that this be memorized. Now remember, it's right triangle trig because it only works with right triangles. Okay, we'll spend a little bit more time talking about cosecant, secant, and cotangent, but as far as now, I just need you to know cosecant is the inverse of sine, secant is the inverse of cosine, cotangent is the inverse of tangent. Okay, so ways to memorize your right triangle trig. All right, there was some choices here. I may or may not put this information in the email. I'm kind of short on time, so I'm just going to go ahead and jump right in. I have several examples. There are a lot of problems in 702 and 703 that you need to know for later units, later sections in Unit 7. You also need to know some right triangle trig to do things that we're going to do after Christmas. This is a skill, even though you might not have a quiz in 702 and 703. These are major skills. It's almost as important as factoring. So knowing this right triangle trig, it comes up over and over and over again. So that's why I wanted to do a lesson on 702 and 703. And I'm sorry we didn't get to do it in a live class setting, but hopefully this video will give you some information that you need. So a lot of problems, students think they have to use their calculator, and you don't. So this problem says list the sine, the cosine, and the tangent from angle A. So you're going to locate angle A, and you're going to say sine of angle A equals, and remember, SOHCAHTOA, or some old hen, so opposite over hypotenuse. And I'm just going to write opposite over hypotenuse, and we're going to go opposite of angle A is 12 over hypotenuse is always the side opposite of the right angle is 13. And then you're going to check to see if it will reduce, and 12 over 13 will not reduce. All right. Cosine from angle A. That's all you do. That's the answer. That's the sign. That's all they want. They don't want you to put anything in your calculator. So a lot of students overthink this and they try to put things in their calculator. All right, cosine. Cosine is going to be adjacent over hypotenuse. So the adjacent leg, remember the leg can never be the hypotenuse. So it's going to be adjacent over hypotenuse. I'm going to do A for adjacent, H for hypotenuse. So the adjacent leg is going to be 5 over the opposite of the right angle is always the hypotenuse, 13. Check to see if your fraction will reduce. If it won't, then that's your answer. And then we're going to do tangent from angle A. Tangent is opposite over adjacent. And if we erase this again, we're viewing this from angle A, not angle B, not angle C, but from angle A. So we're going to go opposite. That's going to give me 12 over adjacent. That's going to give me 5, and 12 over 5 will not reduce, so that's my tangent. So probably about half of my examples, we're not going to touch the calculator. We're just going to set up the fraction, and we're going to make sure the fraction is reduced. Okay, so let me double check my answers here. I got 12 over 13, 5 over 13, 12 over 5. Excellent. All right, this problem says, what is the cosine of z? Just cosine. So let's write cosine of z. Let's remind ourselves that cosine is adjacent over hypotenuse. Let's go find angle z. Let's go adjacent. Okay, so this is your hypotenuse. So you can't use the 15. So 15 is not going to be the adjacent because 15 is going to be the hypotenuse. And then adjacent would be the side that the leg that forms the right angle that's adjacent to angle z. That's going to be 12. So it's going to be 12 over 15. Both of these can be reduced by 3. So 12 divided by 3 is going to give me 4, and 15 divided by 3 is going to give me 5. And that's all they wanted in this problem was the value of the cosine. See, sometimes we make the problem harder. I'm really bad at this myself. All right, this one's a little bit harder because it's actually giving you the cosine. So it's saying the cosine of angle A is 3 over 5. So remember, cosine is adjacent over hypotenuse. So I'm going to find angle A. Adjacent is going to be 12. And you're going, well, I know 12. Why are they telling me that it's 3? So let's just write it down for a second. 5 is the hypotenuse. So let's go opposite of the right angle. So what's going on here is 3 over 5, since 3 is smaller than 12, then 3 over 5 is the reduced adjacent over hypotenuse. So we know that the adjacent was 12, but it got reduced to 3. So they're wanting to know what is the hypotenuse that gets reduced to 5. So you say, well, 12 divided by what number is 3? So we divided 12 by 3, or you could say 3 times 4 gives me 12. And so to get from 5 to this bigger number, which is going to be your true hypotenuse, we're going to have to do 5 times 4. So that's going to tell me that my hypotenuse is 20. So think about it. Adjacent over hypotenuse, that'd be 12 over 20. Once you divide the top and the bottom by 4, you'll get 3 over 5, which matches up with what's going on here. So it says, what is the length of side BC? So they're looking for this side. Okay, so let's talk about what we know now. So it's like we had to do, we had to go to step 1 to get to step 2. So we know this is a right angle. We know this is 12, excuse me. We know this is 20. And now we're looking for this side, which is BC. So now I would just use the Pythagorean theorem. So remember, that's a squared plus b squared equals c squared. A and b are always your legs. So a and b could be 12 or x, it won't matter, but c has to be the 20, okay? C has to be 20. A or b, you can mix those up and it won't matter. So I'm going to do 12 squared plus, we'll do x squared. 12 squared plus x squared equals 20 squared. So that's 144 plus x squared equals 400. Subtract 144 from both sides. I can probably do that in my head, but I'm going to use my calculator. That's going to give me 256. When I have an x squared and I want an x, I take the square root of both sides. That's going to give me positive or negative 16, but I'm talking about the side of a triangle, which has to be positive, so you have to choose the positive there. So that's going to be 16. All right, so to me, this one was, as far as level 1 being the easiest, level 10 being the hardest one, this one kind of got to a 6 or a 7 because they didn't give you direct information, but they gave you enough information for you to find the hypotenuse, and then you can come back and find side BC. All right, and this problem is asking you, again, for the value of the sine of C. So this would be, to me, an easier problem. Find angle C. Remind yourself that sine is opposite over hypotenuse. So you'll go opposite over hypotenuse. So that's going to give you 8 over 17, and that will not reduce. So that would be your answer. So to me, you go for something like 3, that's like a level 6 or 7, to number 4, which is back down to like a level 2 as far as being not that difficult. Didn't have to pick up my calculator. I just had to know sine was opposite over hypotenuse. All right, let's take a look at number 5, and we'll start to get into when we use our calculator. It says given triangle ABC, so there's not a diagram. Super important. I know that I can't do this problem without a diagram, so I draw a right triangle. It doesn't matter. Put a right angle in there. I promise it's going to work out. It's even going to tell you where the right angle is. So you have to put C where the right angle is. It won't matter where A and B goes, I promise. And it says AB has a length of 18 centimeters, so that's the hypotenuse. Angle A is 22 degrees. And then it says find BC. So BC is going to be this leg. I'm just going to put an X there because it just makes it easier to use X than BC. So in this problem, I'm going to have to set up an equation using right triangle trig, and then I'll have to solve it, and I will have to use my calculator here. So what I've been taught to do is I look at the angle that I have. I think about where the X is. That's going to be the opposite leg. I think about where the 18 is. That's going to be hypotenuse. So I think opposite over hypotenuse, and then I know that that is sine. So I don't know the adjacent leg. It would be right over here to angle 22. Everything is viewed from the angle here. Since I know the adjacent leg, then that tells me I can't use cosine because cosine has adjacent in it, and so does tangent. So I'm going to say sine of 22 is equal to the opposite leg over the hypotenuse. So again, sine of 22 degrees is equal to x over 18. I'm going to make a proportion. So a proportion is just a fancy word for a fraction equals another fraction. I'm solving for x, so I'm going to cross multiply. X times 1 is x, and then I'm going to have 18 times the sine of 22 degrees. I'm going to put this in my handy dandy calculator. You are going to have to make sure that your calculator is set for degrees. There is another measure of angles called radians. We will study that later on. But if you keep getting the wrong answer, if you're doing a multiple choice question or you're doing your worked examples in your OLS and you're not getting the right answer, it might be because your calculator is not set up for degrees. I'm going to open up my Desmos Scientific, which is what I've been using lately, instead of the TI-84. And I'm going to do 18 times sine 22. 18 times sine 22, and I noticed in your OLS that they're asking you to round to the nearest tenth, so that's going to be 6.7 because the 4 is not going to be big enough to round the 7 up, so I'm going to keep that as 6.7. If they do give you units, you'll fall back to whatever unit they gave you in the problem, so this is going to be 6.7 centimeters. All right, number 6 is asking you to find x. So again, I am going to view this from the angle that I'm given, which is never going to be the right angle. Okay, you're always going to view it from the other angle, never the right angle. So let's look at what we have. We have the adjacent leg and we have the hypotenuse. So since I have adjacent and hypotenuse, I know this problem has to be worked with cosine. I don't know the opposite leg. That means you can't use sine and you can't use tangent. So we're going to set this up as the cosine of 52 degrees is equal to 7 over x. I'm going to take cosine of 52, put it over 1, make myself a nice little proportion, so I can always cross multiply. So that's going to give me x times the cosine of 52 equals 7 times 1, which is 7. I'm solving for x. Since x is being multiplied by the cosine of 52, I'm going to divide both sides by the cosine of 52, and then I'm going to put this in my calculator. And I am going to get approximately, if I round to the nearest tenth, I'm going to get 11.4. And they did not give me centimeters or inches, so I'm not going to put any units on that. So these last two, we're going to have to use the calculator to find the cosine of 52. That's not just going to be something that we know. Let's take a look at number 7. Number 7 is asking us to find the measure of angle C. So this time we're looking for an angle. So I am going to circle this. If I could draw a flag, I would say, hey, a red flag is waving. Anytime I'm looking for an angle in a right triangle and I have to use sine, cosine, or tangent, when I put this in my calculator, because I'm looking for an angle, I'm going to have to use the second button because I'm not going to actually be finding the cosine, the tan, or the sine of an angle because I don't know the angle. So you've got to tell your calculator that you're looking for the angle. So anytime you're looking for the angle, you have to use the second key. So number one, that's something that you have to know. So go look at what you know. So viewing this from angle C, because that's what we're looking for, we know the opposite leg is 13 and we know the adjacent leg is 6. So opposite and adjacent goes with tangent. So we're going to set this up as the tangent of angle C is equal to opposite over adjacent. Then we straight up use our calculator. We do second, and then we do tan, and then we put in 13 over 6. You have to do second tan to tell your calculator that you're looking for the angle. If you don't do this, your calculator's not going to know that you're looking for an angle, and my calculator's going to give me 65 degrees. I just rounded to the nearest whole number because I went and looked at the OLS, and this one told me just to round to the nearest whole number. So you have to use the second key before you hit sine, cosine, or tan. It could be sine, it could be cosine, it could be tan, but anytime you're looking for an angle, you have to hit that second key. All right, let's take a look at number 8. There are some word problems. We just call these application problems. So as soon as I start reading this, I realize it's going to match up with a right triangle. So I have to have a picture. It just helps me. You might be able to do this without a picture, but I always draw a picture. So draw your right triangle. It doesn't matter if it's perfect. Just make sure it's got a right angle. It says a wooden board is leaning against the wall. The base of the board is 6 feet from the wall. So leaning against the wall, this would be your board. And it says it's 6 feet. This board that's leaning, so that's what makes it the hypotenuse, is 6 feet from the wall. So this is going to be the wall. This will be the board. It says, and the base of the board forms a 55-degree angle. So here's your board. Here's the base of the board. It forms a 55-degree angle with the ground. What is the length of the board? Oh, by the way, it says I got 6 feet here. So it wants to know the length of the board. So we're going to let X be the board. We're going to view this problem from our angle, always viewing it from the angle, not the right angle. And let's look at what we know. So we know the adjacent leg is 6, and we're looking for the hypotenuse. So if we're dealing with adjacent and hypotenuse, that means we have to choose cosine. So you have to look at what you know and what you don't know. You don't know the opposite side. So that means you can't use sine and you can't use tangent. So we're going to say cosine of angle 55 degrees. We know the angle this time. Equals the adjacent leg, which is 6, over the hypotenuse, which is x. Put cosine of 55 over 1. Make yourself a little proportion. Cross multiply. That's going to give me x times the cosine of 55 degrees. Equals 6 times 1, which is 6. Divide both sides by the cosine of 55. Those will cancel, and we put this in our handy dandy calculator, and we round to the nearest tenth. And that's going to give us 10.5, and they did tell us feet, so we would add feet to that. All right, number 9. Melissa is standing 40 feet from a tree. The angle of elevation from where she is standing to the ground to the top of the tree is 50 degrees. How tall is the tree? So again, this is a word problem. The first thing that I do is I'm going to draw a right triangle. Again, it doesn't have to be perfect. Do your best to put a right angle in. Put a little box in. It says Melissa is standing 40 feet from a tree. So unless they tell you that there's been really, really high winds, trees are going to be your vertical leg. Okay, so this is going to be the tree. 99% of the time, whatever is standing tall, pole, tree, person, they're going to be the vertical leg. Okay, it says Melissa is standing 40 feet from the tree. So Melissa, I'm not an artist, don't laugh. She is standing 40 feet from the tree. it says the angle of elevation, and I snipped this from somewhere on the internet. Angle of depression. Angle of depression, you're looking down. If you're depressed, you're down in the dumps. Angle of elevation, you're looking up. So this is Melissa. We'll draw her some hair. She is looking up at a degree of 50 degrees. How tall is the tree? So we're looking for X. So we don't know the hypotenuse. So the only thing that we can use is tangent. So we're going to do tangent of 50 degrees equals opposite over adjacent. So that's going to be X over 40. Cross multiply. X is going to equal to 40 times tangent of 50. Put this in your handy dandy calculator. Round to the nearest tenth. And I skipped this problem for some reason when I worked it out. And that's going to give me about 47.7, and that would be feet. So I really suggest drawing a right triangle. If you can just see it in your mind, then bless your heart, you're so much smarter than me. I have to draw the picture. That's just the way it works for me. Last one. A 96-foot tree. So again, I'm going to draw the right triangle. It doesn't have to be perfect. Here's your tree. Unless they tell you there's been a hurricane and the trees have all fallen down, it's always going to be the vertical leg. A 96-foot tree, so they're telling you how tall it is. Cast a shadow. Shadows are on the ground. So this would be the only piece of the right triangle that could be on the ground. That's 120 feet. What is the angle of elevation? So the sun, again, don't laugh at my artistic inabilities, but the angle of elevation would be looking up, okay, to get to the sun, and they want to know what this angle is. So I'm just going to put X. So on this one, we're looking for an angle. So what do we know? We know from that angle the opposite and the adjacent. We don't know the hypotenuse, so that forces us to choose tangent. So tangent of angle X is equal to opposite 96, adjacent 120. Because we're looking for an angle, I always have to do second because I have to tell my calculator I'm looking for the angle. So you're going to do second tan, and then you're going to do 96 divided by 120. And then you're going to round to the nearest whole number, and I'm getting 39. Let me try it really quick. Let me double check that. Second tan, 96 divided by 120, 39 degrees. And if it tells you to round to the nearest tenth, you can round to the nearest tenth. But that would be degrees because we're looking for an angle. Hopefully this was really, really helpful. I'm going to email it out to y'all today. Again, I'm sorry I had to be out of the office today. It was something that I could not help, but I did want to send out a lesson on 702 and 703. Please, I'll also send the whiteboard link. Please make sure that you, if you would like, save the whiteboard. It's got a lot of really good reference pages, information. It's got that Sokotoa and some old hen. I caught another hen taking notes away. Way for you to memorize. You do need to memorize sine, cosine, and tangent. It's going to pop up over and over again in your future, and people are going to expect that you have that memorized. Hopefully this was helpful. Y'all can email me if you have any questions or concerns. Thanks. Bye.